Hello everyone, this is Rob here, and in this video I'm going to show you how to configure NAT or Network Address Translation on a Cisco iOS router. So I've laid out a topology in GNS3. This is an extremely simple, very basic example. This is what you're primarily going to see in a regular home network, very small business, where your internet connection terminates into your router, and all of your hosts, your computers, your network hosts, everything from your printers, phones, etc., wireless access point, is going to connect into this. And well, let me go ahead and show you right here. So if you look at this topology, we have the ISP. So this is going to be the internet service provider, as depicted by this cloud right here, and a loopback of 8.8.8.8. The reason for that is so that way we can verify at the end of this that we do have reachability, and we have this layer 2 segment here between the ISP and the customer router is 75.129.110.0/24. So our router is going to be assigned an IP address via DHCP from our ISP, and then NAT is going to be occurring right here at this boundary. So all of our RFC 1918 addresses are going to be translated to this public IP that we have on this, that is obtained via DHCP on this interface as it goes out to the internet. And then just a very basic LAN switch right here for all of our hosts to connect to, and all of that stuff. Just very basic layer 2 switch, nothing fancy, no VLANs, nothing like that. So again, like I said, what you're going to see in a very basic, very simple home network, small business, something of that nature. So the only thing I will point out is that right here, you would have like a cable modem or something like that. So this would be like coaxial cable terminating into the cable modem and then handing off the Ethernet to the router. But since this is a demonstration, I think that everybody can see what's going on here. So at the end of this video, you will have learned how to configure your NAT inside and outside interfaces, your NAT access control list, and your NAT statement to complete the whole picture and get NAT up and running. So I'm actually going to do this on physical equipment. That way we don't have to worry about any bugs or glitches or inconsistencies with the emulation or virtualization software. I've had very good luck here with GNS3, but there are some things once in a while where you just, even with a very basic configuration like this, you don't want to spend any time trying to figure out if it's an issue with your network emulation program or if you did something wrong. So what I'm going to do is set this up on this stuff right here. And of course we're not going to be using all of it. This is my Cisco lab, which consists of 5 routers and 5 switches. So I'm going to, first of all, I need to get rid of all this stuff from a previous lab, and then I'm going to label everything ISP, customer router, and LAN switch, and show you how to configure it on a live Cisco device. So let's get started. Okay, so here we have it, a very basic setup. So this is going to be our ISP, so that would be the cloud in the topology that I showed you. And this has that loopback, 8.8.8.8. This is going to be the customer router. So this would be where your internet would be coming in from your cable modem, and then it goes up here to the switch. So all of your clients are going to be connected up here. So all I need to do is just get everything configured, and we'll get right into getting NAT configured. Okay, so I just configured the ISP router. So as you can see, we have a okay. As you can see right here on Gigabit Ethernet 00, we have the what will be our default gateway for our customer router. So 75.129.110.1, and then that loop back of 8.8.8.8. All right, next I'm going to configure the customer router. Okay, so here we are sitting on the CLI of the customer router. So once again, this topology looks like this. So we have our ISP and then customer router, which is then connected to our LAN switch. So what we're going to do is enable this interface, Gigabit 00, and then set the interface to obtain an IP address via DHCP. That way we're going to get an IP address from the provider. We'll go no shut, and then IP address DHCP. And give it a second, and we should obtain an address from the ISP. Okay, there we go. Gigabit Ethernet 00 is assigned DHCP address 75.129.110.3. Make sure we have reachability to the default gateway, or the address on our provider's router. So that would be 110.1. We do. Now we can also actually so this also assigned us our default route. Now, most of the time, your provider is going to assign you a default route. In the case that doesn't happen, what you would need to do is go into global config mode and then type in IP route 0.0.0.0 0.0.0.0, and then the default gateway, which is going to be normally the subnet that you have been assigned an address in, and then a 1 at the end, or if your ISP provided you some documentation. Maybe you signed up for some static IP addresses or something, and you have to manually configure this sort of thing. So then at that point you would just type in the whatever the gateway of last resort would be. So in this case, 1. Of course, like I said, it was automatically assigned, so I'm just showing you how you would put that in there statically. So okay, so at this point we have an IP address on our WAN side, on the WAN interface. We have a default route. So at this point we can ping 8.8.8.8. So, okay, so let's go ahead now and let's configure our LAN interface. So again, we are now going to configure Gigabit 0/1 on the customer router, which is going to be our LAN interface, that interface that the switch is going to be connected to. First, we'll do a no shut, and I am going to stick this in the 192.168.1.0/24 subnet. So we're going to give this an IP address of 192.168.
1.1, subnet mask 255, 255, 255, 0. Now, this can be whatever you want it to be for your LAN side. So I just chose this. You could have it 192.168.2.1, 10, 16, 20.1, whatever you want. It doesn't even have to end in 1. Whatever the IP address of this interface is what is going to be the default gateway for all of your clients on the LAN. So now that we have this set up, let's do a little experiment. Let's try to ping 8.8.8.8 with the source interface of gigabit 0/1. So now you see what I was talking about. We do not have reachability. As a matter of fact, the traffic is getting there. The traffic is not getting back to us. Now, again, in the real world, the traffic wouldn't even be getting there. It would be this private Class C address. This traffic would be dropped right off the bat. So, but this is going to be the subnet that all of our LAN clients are going to be. They're going to have an IP address in this range. So, the proper way to do this would be to configure a DHCP server. And actually, I'm going to show you how to configure a DHCP server on a Cisco ISO or iOS router in an upcoming video. Right now, what I'm going to do for testing is I'm just simply going to statically configure the TCP/IP settings on my client computer that I'm going to be using to test this. So let's go ahead and get NAT configured at this point. So the first thing I like to do is set the inside and outside interfaces. So there's really no specific order. If you want to configure your access list first, or if you want to configure the inside and outside interfaces second, or vice versa, it's up to you. I normally configure those first. So we're going to tell the router that this is going to be the NAT outside interface, it's gigabit 00, and we're going to tell the router that this right here is going to be the NAT inside interface. Basically saying all traffic coming into this router from the inside to outside should be NATed to an address in this subnet. Well, actually, we're going to set it to NAT the traffic to the address that's been assigned to this interface from the subnet. Actually, I plan on covering NAT pools in a later video as well. So when we get into more of the advanced NAT functionality. But for now, we're just going to set our NAT outside and inside. And then I'm going to show you how to configure the access list to define that interesting traffic to the router, what traffic should be translated. So first we'll go to gigabit 00 and IP NAT outside. Okay. Interface gigabit 0/1, IP NAT inside. Okay, and that part is done. So now we've defined our NAT inside and outside interfaces. Now we have to create an access control list to tell the router what traffic should be translated. Now, in more advanced NAT configurations, or if you're using NAT with route maps, or say you have an IPsec tunnel on your router and you need to deny translations on site traffic, you would be more specific, more granular in this access control list. Again, like I said, this is supposed to be a simple example, and with that being said, for this example, we're just going to do a permit IP any. We're just going to say NAT everything, just like any consumer grade router you're going to pick up from the computer store or Best Buy, where it's plug and play. You just you plug in your internet to the yellow port and plug in your computers to the blue ports, and it has built-in wireless and everything. Everything is just automatically configured to be NATed by default. So what we're going to do is go IP access list, and I do a named extended access list. Again, for this simple example, you could do a standard access list, which is just going to define the source. So we could do a standard access list and just do permit any. I like to do an extended access list, and especially named, not numbered. Naming your access list is more tangible because we're going to name it NAT. So when you look at that, you're going to remember that access list is for NAT. But again, I like to make an extended access list because you can define, you can make, block, permit or block traffic based on source or destination. So, and like I said, that will come into play later on down the road. So we're going to go IP access list extended NAT, and then just do permit IP any. Now, actually, if you were to just define the traffic that we have on our LAN, you could go permit IP 192.168.1.0, and then the wildcard mask, which is the inverse subnet mask. So if our subnet mask is 255.255.255.0, the inverse of that would be 0.0.0.255 to any. And that right there would basically say NAT anything in the 192.168.1.0/24 subnet, NAT that. And then you should know also that at the end of every access list, there's an implicit deny statement. So everything else would be denied. So if you had another network in a different subnet, then that traffic would not be translated. And that's how you would define in a more complex setup. Hey, what traffic should be NATed? What traffic should be NATed? Going out this interface versus this other interface, or what traffic should not be NATed if it's traversing an IPsec tunnel or something like that. So, but anyways, like I said, keeping it simple, we're just going to do permit IP any. Okay. There we have it. So now we have our NAT statements configured, our inside and our outside. We have our NAT access control list, which is going to allow all traffic to be translated. Now the only thing left is to configure our NAT statement to complete the picture and get everything working. So we'll do that by going IP NAT inside. So we want to look at the inside and do the question mark because we want to define the source list. And remember that access list we just created named NAT, which is defining the inside addresses to be translated. So we go IP NAT inside source list NAT, do the question mark again, and then we have interface or pool. Like I said, I'm going to go over NAT pools in a later video, but right now we just want to translate those addresses to whatever public address has been assigned to our WAN interface. So we're going to say interface, and then gigabit. Oh, that just logged me out. Interface gigabit 00, which is where our WAN IP is going to be. And then overload. The overload command says, well, let's say you didn't configure overload. What's going to happen is you're going to have one translation and then nothing else is going to be translated. So by saying overload, you're basically saying, hey, overload all of these private IPs to this one public IP. So we're not doing a one-to-one NAT translation. We want to take all of our private IPs and overload them to that one public IP. So make sure you don't forget to put the overload command when you type out your NAT statement. And press enter. All right, and then let me just bring that command up one more time so you can go over it. So you want to do IP NAT inside source list, which is where you're going to define that access list. Now, you don't have to name it NAT. You can name it whatever you want. We named it NAT, so source list NAT. So we're saying, hey, we want to anything defined in this access list is going to be NATable, if you will. And then what do we want to NAT it to? Do we want to NAT it to a pool? Do we want an interface? So in this instance, we're going to do interface gigabit 00, since that's our WAN interface, and then overload. It's as simple as that. So now we should be able to go ping 8.8.8.8, the source gigabit 01, and we have reachability. Let's do a show IP NAT translations, and we see that we have ICMP message. That was our ping that we just sent. Inside global is going to be the WAN IP. Now, this is confusing to a lot of people, and this was confusing to me at first. So your inside local is going to be your private IP addresses inside your network. Your inside global is going to be the WAN IP address that's assigned to your provider, or by your provider, or if it's statically set, whatever, that is going to be your inside global address. That the NAT's the interface that you have defined the IP NAT outside statement, and then outside local, outside global are normally going to be the same, always, and that is going to be the address that is on the outside of your network. So in this instance, like I showed in the topology, 8.8.8.8, which is our fake virtualized internet. So these addresses, whichever one you're assigned from your ISP, that would be inside global. This would be inside local. And then the 8.8.8.8 would be outside local. But as you can see, we have a translation here. It's basically saying inside local, that 192.168.1.1 is translated to 75.129.110.3, which is the address on our WAN interface. And we're going out to 8.8.8.8. We can also do a debug IP NAT. Ping 8.8.8.8 one more time and watch the magic happen. See? Source 192.168.1.1 to 75.129.110.3, destination 8.8.8.8. When the traffic comes back in for 8.8.8.8, we see the source here. We see the destination is for our public IP 75.129.110.3, translated back to 192.168.1.1. Okay, undebug all, and then the last test is going to be hooking up a computer and testing to see if we have reachability. So what I'm actually going to do is I'm going to patch in the on my patch panel. I'm going to patch in the computer that I'm on right now to the LAN switch. Okay, so now I am connected to the LAN switch. I've connected the computer that I've been configuring the Cisco router on. I've patched that into the LAN switch. I have plugged it into port gigabit 1/0. So, let's see, do show run interface gigabit 1. I'm sorry, 1/1. No 1/0 on switches. Okay, so what the first thing you want to do on a Cisco switch, now you don't have to use a Cisco switch. I know this video is about configuring NAT on a Cisco router, not how to configure the Cisco switch. But in this example, if you want a little bonus, we are using a Cisco switch. We're not using any of its fancy features, no VLANs, no routing, nothing like that. But the one thing that you will want to do on a Cisco switch, or any manage switch out of the box, since it runs spanning tree protocol, is you want to let that switch port know that there's a host connected to it. So you can either do, on a Cisco switch, you can either do switch port and then host, which will disable spanning tree on that port. So the reason for this is so that way you don't have to wait. You don't have to wait when you plug in a host to that switch port. You don't have to wait for those BPDUs for spanning tree to be exchanged, and for it to find out that it's a port that shouldn't be blocked. That sort of thing. You just move right into a forwarding state when your computer is plugged in, or your computer first boots up. So the other way you can do it is spanning tree. I believe spanning tree mode or spanning tree port fast. It's probably spanning tree port fast. Spanning tree port fast. If you look, warning, port fast should only be enabled on ports connected to a single host. Connecting hubs, concentrators, switches, bridges, etc. to this interface when port fast is enabled can cause temporary bridging loops. Use with caution. Port fast has been configured on gigabit Ethernet 1/1, but will only have an effect when the interface is in a non-trunking mode. So this will not work if the switch port is configured as a trunk. Of course, in this scenario, it is not. And also, just to make sure, we want to statically configure the switch port as an access port. So switch port mode access. Okay, and then like I said, since we do not have DHCP configured on the router, I'm going to statically configure this computer with the TCP/IP information. And I think in my next video, I'm going to show you how to configure DHCP on a Cisco router. So that way you can just plug in your computer. You will be, it will obtain an IP address, your default gateway and DNS servers, right from the router itself, and you will be good to go. So let's go to Ethernet, IPv4, and we are going to go, remember we set that LAN interface in the 192.168.1.0 subnet, so we'll just go 1.5, why not? Class C address, /24, so subnet mask is correct by default, so 255.255.255.0, and the default gateway is 192.168.1.1. That LAN interface on the Cisco router we just configured. Okay, so let's open up a command prompt window. We'll do an ipconfig. Oop. As you can see, IP address, subnet mask, and default gateway. And let's see if we can ping 8.8.8.8. And we can. So we have successfully configured NAT on our Cisco router in a very basic way. And just for fun, let me go ahead, let me switch this console cable back over to the customer router, and we'll do a debug. We'll do a debug as we ping our virtual internet, our 8.8.8.8 from our host. So we'll go debug IP NAT. Bring our command prompt window and ping 8.8.8.8. There you go. There's our source. The host that we just configured manually, 192.168.1.5. It's natted or translated to 75.129.110.3. The IP address on our WAN interface to 8.8.8.8, and then of course return traffic. Destination to our public IP translated back to 192.168.1.5. And to show IP NAT translations. We can see all of that right here as well. And there you have it. That is how you configure NAT in a very basic way on a Cisco iOS router. I'm going to include the topology in the description of this video, as well as I'm going to include the commands in the description of this video as well. So I hope that this video was informative. I hope you learned something. Feel free to reach out with any questions or comments. Of course, if you like this video, please hit the like button. If you're not already subscribed to my channel, I would very much appreciate it if you subscribed. And I will see you in the next video. Have a great day, everybody, and thanks for watching.